minute early. How insane is that?
No, you see that's the issue with the company we were talking about. You're never going to know what you're going to get from them year on year. It happens all the time. Oh, we live.
We might be, yeah. I tried to go live.
Oops.
No, it's like life is like a box of chocolates. You never know what you're gonna get. Run, Forrest.
Or what you're going to be sampled.
All right. How is the audio, chat? How are we doing? If everybody can hear me clearly, say shillelagh.
Shillelagh.
Well, Chad has to send it back to us, or onomatopoeia.
Yeah. No, I'm just thinking of Saints Row, the bar Shillelagh, I think. I don't know. I do enjoy me a bit of Saints Row. Audio okay. 1 2 check. 1 2. How many benchmarks have you won today? 1 2.
Okay, they can hear us, so I think it's pretty good. So yeah, check it out. You can see my test bench here. I have the 12 core, and then I have a tiny little lunchbox computer because I don't know why we need them. Like I went through all the effort to set them up, and it's like, oh my gosh, it's fast.
I was wondering why you had systems running on your desk.
Well, I mean, somebody might be like, I don't believe you, and it's like, all right, let me just run this. It's like, oh, look at that. Oh, the latency 62 nanoseconds. How insane is that?
Guess the latency of this.
What is that one? I can't
This
even
is a
see it.
Carrizo desktop. Carrizo desktop A series.
Uh,
AMD A series.
110 nanoseconds.
110 nanometers, maybe.
All right, I'm literally launching Ada64 Engineer so it can be just running in the background. We can contend with the fan noise and deal with all that.
It's for one short moment in my life, I'd have no test systems running.
No.
It's been a long few days.
Yeah. Yeah, it certainly has. But this launch, I don't know. This launch has been really interesting. You know, it's a little bit like the dog that caught the car. Okay, now what?
It's I mean, you have to hand it to a company that's a tenth of the size, right?
Yeah.
I mean, Intel, what, 110,000 people? Now, not all of them work in a CPU department. You know, they got 15,000 software engineers, but still, you know, not everybody at AMD works on CPUs. So it's been a journey, and we've been along for the ride.
Yeah,
Oh,
it
and
has been
have they
fun to
taken
watch.
us for a ride?
It has been a lot of fun. I mean, you know, well, I mean, I don't know. It has been a lot of fun. Just, I mean, since Ryzen launched until now, and the consistency of execution, I think, is more important than or as important as what they've done because consistency of execution the last I don't know what 5 generations, 6 generations. I mean, if you've got the lens of hindsight, you know, you could look all the way back to like Sandy Bridge. Everything since Sandy Bridge has been more or less an incremental upgrade.
It's one of those things where, okay, you had TikTok for so long, but it's all under the whole core. The whole layout of Intel's always been like a core sort of layout. You've integrated new structures like micro caches and expanded, you know, make the decodes wider, make buffers bigger. You can only go so far before you have to actually do a full ground up redesign, you know, as we see with Sunny Cove. But
Yeah,
yeah, no,
that was one of the things that was really surprising. And I mean, your guys' article covered a lot of this stuff really well on the technical side of it. I mean, Zen 3 is a re-architecture, and 32 megs of cache. You can't just shovel more cache into the CPU and expect good things. And in the technical deep dive, you know, they said it's 6-7 cycles extra to go from 16 megs to 32 megs. So the cache is much slower. That makes your latency worse. So it's even more of an accomplishment because the hill that they've climbed is even higher of their own making because they needed to offset the fact that they have more cache, because there are some things that definitely benefit from more cache, and latency doesn't hurt it, but latency hurts gaming.
It's increasing the size of the cache in general makes it slower. I mean, that's just a fact of life because you've got more of the cache to transverse when you're searching for a cache line.
Yeah.
And there are tricks on how you arrange the associativity to help bring it down. I mean, do you remember when was it AMD or Intel went from a 256K to a 512K L2, and they kept the latency the same because they were doing some tricks with associativity. Now that all costs die area. So when you're designing this, it all has to, it's the trade-off. Do you want to spend the die area to keep the low latency? There's extra power management you have to go in with all that. And then do you have enough physical space? I mean, sometimes caches are limited just because you don't have enough space in between the other gubbins of the core, right?
Yeah. Yep.
So interestingly, one thing that may be solved when we go 3D.
Then you have heat problems.
Yeah, but I mean, you're looking at the Zen 3 core with the 32 meg cache. It's funny how when we speak about these from a press perspective, we never differentiate between, say, like a private cache and a shared cache, and then actual what each core is allowed to access. I forgot where I was going with that. Oh, it's been so. I don't know about you, but I've also been staying up and watching election coverage. So add in Zen 3 on top of that.
It's been like a slow moving train wreck. I know that. I don't need to watch the news coverage to know that. I don't need to watch the news coverage because it doesn't matter. I mean, it matters, but in the nihilistic,
It's with the UK elections, we have 650 Parliament seats. So if you stay up all night, you have a map, and then if you're really into it, you can color in the bits that declare through the night. Could have tried to do it with states with the US election this time, but I think everybody was too busy.
Yeah, no, it's too. We've had states that are, you would have to uncolor some of the states and then like recolor them because they're like, oh, we're done, and then they're like, oh wait, we've got more. Oh, never mind, it was the wrong color.
But nevertheless, still trying to run that next benchmark. Are you done yet? Are we running Dead Redemption 2, or should we go to World of Tanks, or let's run more spec?
No, I mean there were so many like little things that were like super insane. On the Linux testing, tungsten, like it seemed like I was doing testing with tungsten, and it seemed like tungsten had regressed, and it turns out that they didn't update tungsten's code base, but they updated the helper script, like when you're going to compile it, and one of the dependencies for tungsten is Embry, which is from Intel.
Yep.
And there's a routine in there called optimize for architecture, and it tries to disable SSE3 now, and it's like, what do you do?
Are we playing genuine Intel games again?
Yeah, that's happening in the MKL, and I'm not sure if the Embry one was a mistake or if it was on purpose. But because it's open source, you just modify it, and so I had to like figure out how to do that, and then once I modified it, the performance was good again. But it was like a 3950X could do the hair test in like 17 seconds, and the 5900X can do it in like 12 seconds or 13. But without the optimization, it was like 32 seconds, and I was like, what is going on? And so there was a lot of that.
The way to get around all this bump is where you need to start having processor names with emoji in it.
It crashes because it doesn't have it only allocates 8 bits and it's a 16-bit character.
It's you've got the Intel smiley face, aubergine, man doing this, -G7, right?
I can think of some really colorful emoji to use for the server processors. Oh, I forgot. Oh. We're getting super chats. So yeah, look at that. Oh, I have to scroll for a bit. Esky Monster says, "Long time no see. Happy to see you both. And the PRCPT Planet, which is I think in Taiwan, maybe I don't know, says level 1 potato. Yes, this is the level
Yeah.
1 potato stream. Um, and
No, no, no.
Anton
But potato one tex.
Anton says, "Hello. We have we still have to use Intel CPUs in some workstations due to compatibility issues with some old software for FPGA, Xilinx BTW. I don't think that's going to be a problem anymore in
You
virtualization
say
workloads."
anymore. Um, it's going to be at least 2 years before anything proper happens.
I have a feeling that there's some tech support tickets. They're going to get escalated, though.
It's the best thing they can do with that arrangement, from my perspective, is just to leave Xilinx alone for a little bit and just take some of the natural synergies that come with it, but just let it do its own thing. One of the reasons why I think Intel and Altera didn't work is because they integrated way too quickly, and Altera kind of disappeared as a name from the whole ecosystem
Yeah, that is a
as
good
a
point
result.
because Altera was definitely the market leader at the time that they were acquired, and that did not work out for Intel
No, it's
ultimately.
they integrated too quickly and they shoved every new project onto 10 nanometer.
What didn't? That was,
Yes,
uh,
imagine if Intel consumer processors just missed a generation. It doesn't go well for revenue, customers, deployments, roadmaps,
general happiness inside your programming department.
and general happiness outside.
So I don't know. I don't know if
Yeah.
is there anybody that's watching that hasn't already binge watched 8 hours of reviews from the tech press and everybody else. Because we can give you the 5 minute rundown is kind of fun.
Oh, Alexandros says we should just call it Tex.
What?
Yeah, that works.
USS Liberty Incident. Oh, that's a great name. I'm very happy to see you guys doing a stream for this exciting launch. It's lovely to see Intel's hubris catch up with them. B00 Irish says it's early days for the 5000 series, but do you think AMD refresh early with XT revisions to tackle Rocket Lake?
No.
The 8 core Rocket Lake leaks don't honestly look that great. And they're probably a little slower than what final shipping silicon is going to be, but the thing with Rocket Lake is the single core performance, not multi core, because they're having trouble matching the 10900K multi core. So,
It's I mean, I found it amusing that Intel had to launch 10850K
yeah.
because they couldn't bin enough 10900Ks to meet demand. I mean, don't get me wrong. When you do the Ryzen 5000 versus Intel comparison, because AMD's put the prices up now, which they're fully welcome to do so. You've got the performance, but it means it kind of balances it out a bit more. AMD could have been more aggressive on the pricing for sure, but I think they want to remove this idea that they're always the cheapest option, always the budget option. It's a zeitgeist thing, right? Sales, marketing, Best Buy.
I think that I'm hoping that they realize that there's a way that they can have their cake and eat it too with that, which is 3000 series Ryzen parts because for me, I don't really care all that much about high frame rate gaming, and yeah, there's a huge gulf of performance between the 3900X and the 5900X, but if you can get the 3900X for like 300 US or under, that is a killer CPU for that. And so I'm hoping that the value option is still there with just older parts. Like that would be nice.
My perspective there is they didn't launch the Ryzen 4000 series Zen 2 APUs to consumers. They're as OEMs only. Now, why would you do that? You'd only do that if, one, you're pricing them too high for the consumer market, two, you're not making many of them, or three, you've prepared a fast follow on.
Yeah.
And if you've got a fast follow on, you can instantly see AMD putting 6 or 8 core APUs in that sort of 350, sub 350 bracket. And then that goes up against everything except Intel's Core i9.
Yeah. Yeah, that'll be that'll be quite something. I just got a 4750G. I did the review using it as a Linux workstation, and it holds its own. I mean, to have as little cache as it does, I mean, not really, but comparatively, it's really quite fast. And the Vega 8 with the higher clock is as good or better than um, the Vega 11 in the 3400G. Like I could actually just switching from 3200 memory to 3600 memory was able to match and slightly exceed the Vega 11, because the Vega 11 and the 3400G, at least mine, doesn't do as well with 3600 memory because it's a heat problem.
Yeah. I think we went out and bought all three of the APUs sort of end of August. I tested them, haven't written the review yet,
Yeah,
just because
yeah. I
things
mean,
getting in the way.
it's kind of meh.
It's
I mean, yeah, you know.
it's I mean all the numbers are on an Antec's benchmark database. If anybody watching doesn't know what that is, every time I test a chip, I put it into the Antec database. That's nantec.com/bench when the website is working. And you can go through all of our like 150 benchmarks and do a compare of all the CPUs we've tested on that suite. I think we're up to about 55 CPUs now, and that only ever increases.
Oh, we got
Until...
more super chat questions. Uh, I'm only half paying attention. As I said before, we need more collaboration. Yes, sounds good. I'm all for it. How are the new AMD CPUs at cross compiles? Would there be a noticeable speed up with QEMU AR64 ENV? That is maybe a good thing to run a test on, because the compiles are like everything basically lives in cache again. So I just got some enterprise Optanes to do some more testing with that, because the bottleneck is quickly becoming I/O.
But does your arguably does your I/O change? Your I/O doesn't really change with the new Ryzen chips, though.
No, but the CPU is like, honestly, it's getting to the point where like the 5900X doesn't really matter except for massive compile jobs where you've got that really good parallelization, because it's just down to like Q depth. It's not Q depth 1, but it's Q depth not a lot. And
Yeah.
that latency is sort of being more dominant because the CPU can complete the compile job so quickly, because it's like, hey, load these 7 source files, and then you get those 7 source files, and then it's immediately done compiling it. So there's not like, normally it'd be like, let me get the rest of the next batch of files while the compile is happening, but the compile finishes before the IO even has a chance to make it to the drive.
But I wonder if a bottleneck there is something like the outstanding L3 to main memory requests, because that's definitely gone up in
Yeah,
Ryzen 5000 to 192 per chiplet. So
yeah, it's probably worthy of a good benchmark.
I mean, in our spec testing, industry benchmark spec, the worst performing benchmark only went up by 1%, but that was because it was integer execution bound.
Mm.
Whereas something like libquantum, which is parallel and runs essentially out of the caches, we got 100 and I want to say 114% speed up, which you think shouldn't be possible, but
There's more hardware there to do that work.
yeah, it's obviously it was a case of underutilization of the execution units, and now you can actually feed them quicker. I mean, every time we talk about a new core coming to market, it's always feed the beast. Then if you're feeding it too fast, you make it wider. Then you have to deal with power, and then if you make it too wide, then you're not feeding it enough, so you feed it more.
Well, it sounded like
And
from the technical presentation from AMD, they did literally all of those things, because it was like, oh,
Mm.
we added this, and then that meant we had to do this other thing, and then we had to do this other thing. Oh, and suddenly we've got more loads and stores per cycle. How'd
But
that happen?
it's the fun thing there is they didn't I mean, even though AMD saying it's a new ground up design, they didn't actually do much on the execution side apart from separate out what was the execution units were already there, so that different bits of the execution units could run parallel as if they were their own execution units.
Hmm.
That's why we're moving up from 2 loads in one store to 3 loads or 2 stores.
Yeah.
And dedicated. It's got one dedicated branch unit and one shared branch unit, and store to load forwarding and everything like that. So there's smart management of resources along with physical design, I think.
Well, it's definitely pulled out the win. It's there wasn't really anything that I could find that had moved backwards, which is I think unusual with a lot of these changes under the hood.
So so we did it's we did do a full instruction breakdown. One of my tests is we literally go through every x86 instruction and test performance because there are always tweaks. Whenever you go from like Zen to Zen Plus, there were a few minor tweaks, but it's essentially the same core underneath. Then when you get moved from a Zen 2 to a Zen 3, because it's complete core up redesign, you have the ability to improve a lot of those instructions in terms of performance, or you make some a little worse. So it's always a trade-off. Intel AMD's big thing was faster fused multiply accumulates, FMAs. They're now one cycle lower latency, which means that they're 4 cycle latency, which is the same as Intel now. The thing is, obviously, in the big EPIC chips, you've got 64 cores there doing FMAs compared to 28, right? And
Yeah.
if they're and then whatever frequency they're going to end up playing at, use some of that 7 nanometer. It's going through. I mean, some of the instructions. I'm going to change my screen over.
Oh,
so now that Anantech's finally working, so some interesting things from the cores. Cores can have the ability to skip skip instructions that it doesn't think it needs to either decode or execute. AMD's improved those. AMD's improved a lot of these integer division workloads. These were historically 64-bit integer division. These were historically 90 cycles and 140 cycles. Back when I was doing this sort of scientific compute, it was crazy. It was crazy slow, and you'd actually try and manage your code to avoid avoid divisions, especially interdivisions. Now we're talking 19 cycles, which is just sounds crazy, and that also means AMD is matching Intel there. They've added some accelerators. So when you want to run certain instructions, in this case it's a parallel bits operation, you can either process the micro-ops to go through, and it's previously on Zen 2 that took 300 cycles. Now you've got dedicated hardware, so you can now do it in 3. Whenever somebody says, why are we going to smaller process nodes, what can we do with the extra transistors, that's what we're talking about.
Well, that makes sense, yeah.
One thing that AMD has that Intel doesn't, that we don't really talk about, is SHA-2 instructions, or SHA-256-bit. AMD, for the longest time, or for at least through Zen, has had SHA-2 accelerators. Intel doesn't, because Intel is wanting to go down the AVX 512 route, which is power hungry, and they're trying to catch up on the speed.
It takes a long time, at least in the Linux kernel, it takes a long time to switch into the AVX 512 workload, just because the Linux kernel architecture doesn't like, because you have to save and load those registers, which take time for the context switch, and also the CPU takes a long time to ramp up for the power and stuff.
Yeah, I mean, one thing that I found amusing is that x87, which was meant to be floating point for x86 back in the day, they've actually improved performance of x87. Normally, generation on generation, it gets worse because people aren't using those instructions. So the reason why you would improve x87 is because you've got a customer who's running a lot of old Fortran 77 code.
Hey,
now,
that's completely fine.
How many financial institutions do you think are running old Fortran 77 or Fortran 80 code? Fortran 90 code.
A few really big ones, and no one else.
Yeah. Everybody who you think you should be caring about your money probably still does.
Yeah.
So improving those is it's different. I didn't expect that. And there are a few other, gather and convert and square root act operations that are all improved. It's AMD when they gave us the briefing, it was just the highlights, right?
Yeah,
FMAs, control flow enforcement technology, to protect against shadow stacks for return oriented programming,
yeah.
object programming. But anyway, that um,
Rot
they
rot protection.
rot protection. They highlighted the first major two or three, but there's actually about 100 different changes on the instruction side with the new core, all of which you can read at Anantic.
It is really exciting because
Um,
it's innovation. It's not incremental.
yeah. Have you tried buying a processor today?
Yeah, it's Micro Center. The local Micro Center had a ton of 3600s, but they only had three 3950Xs and about a dozen 3900Xs. But they had probably 50 or 75 30 or 56 5000 series. So fix all that with threes with fives. But 5600s, they had far and away more than all of the other ones combined, and probably two or three times as many overall. But
And
otherwise, yeah, not good.
which ones were you sampled again?
5900X and 5800X.
Yeah, okay, because it's clear looking at all the reviews that AMD did sample different chips to different people to kind of spread out some of the news, so we weren't all fighting for the same review.
Yeah, it's
Almost. So.
I was surprised by the 5800X because the 3800X and the 2800X, those were kind of odd CPUs because you could save money and put it into your GPU, and that's probably the better buy for what you were doing. And so 3700X to 3800X performance delta wasn't really there. But this launch, we don't have a 5700X. We only have the
Yeah.
5800X. But the 5800X seems carefully chosen to challenge the 10 core. I think in my review, I sort of mentioned a couple of times is 8 cores the new 10 cores? Because it goes toe to toe in multi-core, even though it's got two fewer cores.
It's I mean, going from the Ryzen 6 core to the 8 core, you're paying another 50% for another 33% cores. And to be honest, actually, our 5800X was a bit power hungry. On a per core basis, it was consuming about 40 to 50% more power for the same frequency as the 5600X, which I'm not sure whether that was just a quirk of my motherboard, just putting perhaps a bit too much voltage through it. Obviously, the BIOSes are still
Somewhat
pretty
in flux.
early
Yeah.
days right now, so those improvements are likely to come down.
Yeah, I'm running
I
this.
mean,
This is an ITX system which does not have the latest stuff in it still, I guess, and it's an X570, but they're just the
is
the
that got a Nagisa 1081 still?
no, it just got 1.1.0.0 yesterday, I think. So it's still this one is still on that, but like literally just yesterday they were like, here's the new BIOS, and the the one that
Is
they
is
had just published was not great.
is that the MSI Unify?
No, this one's the Aorus X570i.
I I've got that. I think the BIOS was ready a few days before. Though it's
I didn't ask
bec-
anybody for it. I was just like, let's watch the website.
yeah. Um, the thing is, what perhaps people don't know is with these sorts of launches, especially with what essentially is a new family of architectures, um, AMD will work with board partners for specific boards to roll out the first BIOSes for reviewers. So when they came to us and say, "Hey, we're going to sample you," um, we're gonna here are the four boards that we're prioritizing for BIOS updates. And if you're not testing with one of these boards, or if you don't have one of these boards, let us know because we need to get you one. Because you won't get the best performance if you use, one of let's say the
The
mini
sketch.
ITXs. Yeah. So I mean, it's still kind of that way if you're a consumer going out and buying one of these chips now. Give it another 2-3 weeks, and the more performant BIOSes are still coming through. Because I mean, I tested the Gigabyte board, and I was still getting slightly lower performance than I was with one of the AMD priority boards.
That makes
and
sense.
that's
Uh, one of the other reasons that I wanted to work with the ITX board is because this board in particular, I've had really good luck other CPUs, especially the XT CPUs with high clock memory. So like 3800, this ITX motherboard has been plug and play for pretty much every 3800 memory kit that I've used on the XT CPUs that I had, which is not true of other motherboards, even X570 motherboards, because some of them I have are launch day and some of them are retail and newer. And so like the newer boards seem to have some, there's like a Rev 1.01, Rev 1.02, and it's like, hey, this board's more stable with fast memory. But the 5900X and the 5800X both, even on the desktop boards, will go to 3800 flawlessly, which is not something that I can say of the XT CPUs. And I've been able to get 4000 DDR4 4000 working on both CPUs with a lot of fiddling, but a lot of fiddling.
I mean, from a holistic perspective, how much do you care about having faster memory?
It didn't really make much of, like, moving up from 3200 to 3600. I think that difference is worth it and it's easy. And if you can get reasonably fast 3800 memory and it's as easy, then it's worth it. But it's not worth putting a lot of time to move from 36 to 38. 4000, it's not worth the effort.
What if you want a stable system?
I would probably still stick with 3600 because that's what I've been running here forever, even on the 3000 series CPUs, and it's been fine basically.
I'm one of these idiots that even my current system here, it's still running 2133 memory.
Heresy.
And I'm also one of these people that test at JDEC as well.
Oh yeah.
Just because that's the official specifications and industry standards. I don't know. I still end up with blue screens sometimes. So it annoys me. As as a former extreme overclocker, it still annoys me. Super chat from Martin Parker. There's been a lot of talk about current gen Intel versus 5000 series. I'd be upgrading from an i5 Haswell K, probably to 5600. Do you think it's time for the full platform update? If your upgrade cycle is that long, yes.
Yeah.
If you're in a position different to where you were, 5 years ago, 4 years ago, where your upgrade cycle is perhaps going to be a bit faster, then you have to realize that the upgrade cycle from Ryzen 5000 series, there probably isn't one. Because after this, we're likely to go to a new platform. I think that's the plan, isn't it?
I would say so, yeah.
Yeah, because they're going to start talking about DDR5 is going to start rolling out next year, whether we see a consumer platform with it. I mean, don't get me wrong, 5600X, really impressed with the performance. You'll see single-threaded uptick day one, moving from Haswell i5. But it's but bearing in mind what you're going to do. I mean, it's to draw an analogy. If you buy a car thinking about its value in 3 years, when you might sell it, then that's the sort of conversation you might have. If you're going to run it for 20 years into the ground, sure.
Yeah.
But it's
I thought that the 3600 was definitely the sweet spot for the 6-core in the prior generation, but it just did not have enough horsepower and longevity for me. And this seems like I was right, because if you got the 3600 and you were like trying to do the long lifetime out of it, no, you should definitely like ditch that and get something else now that's got a little bit more horsepower. And if you move to the 6-core 5600X, that's really not a side grade because there's so much more there. But if you move up to the 8-core or beyond and keep literally everything else, then that's one hell of an upgrade. But yeah, I mean, replacing the entire platform, the 5600X is more of a, I mean, it really performs like yesterday before the CPUs had launched. The 5600X is basically equivalent to what you would get from an 8-core CPU or better.
It's what amazes me about the 5600X is that single core. I mean, just taking Cinebench R20 result, single core it scores 600. Intel's best Tiger Lake CPU scores 595, right?
Yeah, yeah.
So it's AMD's mid-range beats Intel's best in single-threaded performance,
And I
which is,
think, isn't it true if you use 3600 memory with the 5600X that it's like 620?
I don't know. I didn't test that much. I mean, I know I got a lot more. My multi-threaded results were really, really good for some reason. I On the 5950X, I hit 10K only
Yeah,
by like 9650 points or something. But yeah, being able to hit 10K with the 5950X, it one of the things I find with benchmarking is that I don't like timed benchmarks
yeah,
because as you get faster CPUs, your results kind of move into an asymptote. You slowly reach that single point. Whereas if you have a fixed time and you're calculating rays per second in a renderer, for example, which is kind of what Cinebench is, then your score will only ever go higher, and it's also better to see linear growth.
yeah.
So it's
Oh,
but
yeah.
yeah, no,
We got
it's,
a
it's,
super.
it's, it's,
Go ahead.
Cinebench score is actually based on the time it takes to complete the benchmark anyway. So it's kind of a fudge.
uh, Nori has like I noticed the 28-watt Tiger Lake scores around 595 one thread Cinebench R20. Is there hope that the 125 Rocket Lake will match AMD? No.
It's So the 28-watt Tiger Lake actually turbos during that test up to 50 watts for 28 or 56 seconds, I think, for the whatever power virus Intel deems to define it as. So it's essentially already acting in an unconstrained power environment, which is what a desktop processor would do.
Yeah.
Now the thing is, what frequency are you going to lose or gain going from 14 nanometer Tiger Lake or Ice Lake at 4.8 gigahertz to 14 nanometer Rocket Lake, however many pluses. I mean, you haven't got any super fin to play with on 14 nanometer, so it's backporting cores is a dangerous game, and we will see if it is worth it. I mean, you can argue that what was the stupid leak the other day? 5.6 gigahertz on Rocket Lake?
Not on 14 nanometers.
No, not on 14 nanometer. No, not unless they've actually taken the core and making it 45 pipeline stages. Proper IBM style. Or mandated liquid cooling, or chilled liquid cooling.
Yeah.
Direct die chilled liquid cooling. There we go.
We're gonna etch the CPU in the middle of this really big piece of silicon, but we're actually not going to pack the dies in as close as possible. We're just going to put one die on the wafer, and then we're going to use the rest of the wafer as a heatsink.
Yep.
That's
So
about all you can do.
I mean, that's a funny thing, right? Because we always take it for granted that if you take the heat spreader off and look at the die, that everything you see is being used, or is at least etched in some way, because that would be the most efficient use of the wafer.
Yeah.
But they could have left a 2 millimeter line all the way around the outside to assist with cooling, because the thermal interface that they want to use actually saves them 3.5 cents.
We probably are going to head into that territory before too long because the dies get very small, and if we want them to run fast, they need to use a lot of watts. And eventually, I wonder if the die emits light. Like, I wonder if you can see an infrared glow from it at this point.
Well, was it? You remember when Renoir came out, and then it got into the hands of end users? Was it Frischen's Fritz, the guy who does the really cool die shot
Yeah,
photography?
yeah.
He did thermal imagery of a bare 15-watt Renoir die running Cinebench workload, and obviously because you've not got a heatsink there, the thermals are crazy. But you could actually, using the thermal camera, see which cores were active at what time.
That is exciting. Oh,
It's
Gary gave us $4. Thanks, Gary. How's your launch going? How's things? Like, is it exciting? Woo. There's a few people in the chat that are salty that this is a paper launch. This is less of a paper launch than all of the other launches we've seen so far this year, but the stocks are a little disappointing. But there were a ton of 3600 CPUs in stock. In fact, let's check Micro Center's website and see if they're all gone.
So, I want to put a question to the audience. So, I've been using the same system for 4 years as my main, and it's getting to a point where I want to change it. I'm thinking of going AMD for obvious reasons, though. I would say my use case is more high-end desktop, but I'm gonna try and crack it with a consumer grade system. So I've got before this launch, I was thinking, yeah, I'm gonna use a Ryzen 9 3900. You know, that 65-watt OEM only part with 12 cores. Now I'm thinking, should I use a Zen 3? And I want something that's 65 watts because I wanted less thermals in my office. So do I go with a 5600X on Zen 3 with 6 cores, or should I go with a 5900 with 12 cores of Zen 2? So I've created a poll and I'm going to shove it in the chat.
They've still got a couple of 5900Xs in stock and a couple of 5600Xs in stock, but everything else is gone.
It's because of all the damn reviewers who are keeping it.
Shh, shh, shh. I might have bought some stuff, yeah. It's exciting times. I said 3600 instead of 56. I'm so sorry. I'm never gonna, cause I don't know. That's like, let's figure out chiplets with the 3000 series CPUs. So I'm always gonna be real excited about the 3000 series CPUs, because chiplets are. I mean, it's only a matter of time before we've got chiplets on GPUs as well.
I wonder how far we are away from that.
Get some coffee. You keep saying 3600. I'm out of coffee.
Oh, it's given how little sleep I've had over the last few days. What, 6-7 hours into like 2-3 hour chunks. I mean, the title of my review referenced a mythical 5700X that AMD hasn't launched. So
exciting times. It'll probably launch eventually. I mean, you know, I don't know, or you know, depending on how much stock AMD has of the 3000 series CPUs, just price adjustments for the 3000 series CPUs really rounds out the portfolio really well. I mean, the 39, I've got a couple 3900X systems here. I'm using one Linux, one Windows, and they have held up really well for a lot of different things.
apparently I can't post a link into the chat, so I was going to do a straw poll, but a few people have said, why don't I get used like the 5900X but in eco mode?
Yeah, that's actually not a bad idea. You would probably get like 70-80% of the performance.
Yeah,
and it's still 65 watts.
Yeah, I mean, the all core on the 5600X for 76 watts was 4.45 gigahertz, which is still pretty crazy.
Yeah. I've got to do some. I've got the Dr. Zaber Sentry case here, which is ideally paired with the 65 watt CPU, and I'm gonna give that a try because I was really happy with the 3700X as my home system. With a 65 watt cooling setup in that relatively small case. This thing is awesome if you want a lot of power with portability, because it's basically lunchbox size, but you can see I've got the monitor plugged into something else, but it's tiny and it's really heavy, but it's got a 240 millimeter AIO in it, and it's kind of bananas.
I think you want the system I've got. It's currently in the other room. Maybe I'll get it in a bit. So the XMG Apex 15. It's the laptop with
Laptop
the 16
desktop.
core. So, and the battery in it lasts 40 minutes. It weighs 10, I want to say 10, 11 pounds maybe. But I think I'm gonna try and crack it open tomorrow and install the 5950X in it.
Has it got a new enough BIOS?
I'm sure I can get one to the point where it's at least detected. I can take a screenshot and go,
That will be awesome. Yeah, 16 core laptop. Yeah. This does not have a battery, but it's no compromises. I could put an RTX 3080 in there.
It's back when Threadripper came out, I had a stupid idea of running it in 15 watt mode. And then I realized that the IO die is probably more than that on its own.
Yeah.
But okay, well, even running in 45 watt mode, can I at least get 2.5 gigahertz or 2 gigahertz from 64 cores in a laptop style? Yeah.
3600. Okay. Try to do this. Also saw that G.Skill announced DDR4 4000 memory kits, but I think a lot of people will struggle to get 4000 working, even though it seems like it's possible. But 3800 seems pretty easy.
2133, that's where it's at.
2133 with a cast latency of 7.
The thing I think people have to watch out for is if you're buying 2 sticks of memory, make sure they're dual rank. Because I was seeing some performance regressions with 2 sticks of single rank memory, even 16 gig single rank DIMMs, which are using the really high end. You really need to make sure you're using dual rank memory. I saw some weird performance differentials where if you use the dual rank memory or 4 sticks of single rank, then you get full performance. I mean, this is JDEC. Maybe it doesn't matter at 3600.
Yeah, I don't. When I've run into issues like that, there seems to be some so on the Linux side with like the GPU reset stuff. When you're running it on the ragged edge, you would start to see things like PCIe errors and stuff like that. And I really poked this to try to generate some of those type of errors, and I think they're all handling that behind the scenes. I don't think they forward any of that up to the operating system, because when you're right on the ragged edge of stability with these, it'll give you higher numbers. Like it'll say that it's running at a certain clock speed, or it'll say that the memory timings or whatever, but the performance is actually worse. So clearly there's some sort of retry, retrain, like it knows. I mean, even though DDR4 memory is not error correcting, the standard for it includes things for like a retransmit and things for like errors that occur when data is in flight. So not for correcting a memory error when the data in the memory is at rest, but when the memory is transmitted, from the memory to the I/O die, it knows if an error has occurred. And when you're right on the ragged edge, it seems like some mechanism like that will kill your performance and probably eventually your stability, but mostly it works fine.
Well, I mean, that's the whole point of taking check bits along with you, isn't it? So yeah. And in networking, you have accelerators to do all that checking.
Yeah.
I mean, the whole thing about the Xilinx deal is one of Xilinx's product segments is smart NICs. Now, consumers don't need smart NICs, but when you're dealing with 100 gigasec data flowing in and out of your servers, you rather than using 6 cores to do all that check bits or forwarding, 6 cores out of your 28 core chip, you'd much rather use those 6 cores to actually sell to customers. So you use a smart NIC, and that's the smart NIC market in a nutshell. I mean, I remember going to Supercomputing 2015, which is the big HPC conference that's held every year. It's actually coming up in a couple of weeks now. My first ever Supercomputing in Austin, and I saw a poster for what I thought was essentially one of the first disaggregated smart NICs. So you could put this network chip, and then behind it put either memory or storage or an FPGA or a GPU, and then you connect it into your network, and all your network has these little individual chips. So it would just be like doing NVMe over Fabric. And that was back in 2015, and this was coming out of research in universities and stuff. I still see the same company now trying to sell it, getting nowhere in more modern supercomputing. It was a really fun article that I wrote up that nobody read.
Jim Tracy asks what your bacon number is, or what his bacon number would be.
Oh, if you comment on during the stream, then what will my bacon number be? You have to actually perform or produce for bacon number. For people who don't know what that is, I recently did a video about my bacon number, 6 degrees of separation, how far away I am from Kevin Bacon in terms of, acting credits or producing credits. And when you have a bacon number, if you're also a published scientist, you have a Paul Erdos number. Erdos, the famous mathematician, he has over 1,500 papers, so you can have an Erdos number. And then also in music, you can have a Black Sabbath number, a Sabbath number. And
References
the
to
goal.
Black Sabbath.
So you have to have a music credit with somebody connected through to Black Sabbath. And the game is to have as low of a Erdos Bacon Sabbath number, which is just adding them all together, as you can. And there's about 7 or 8 people in the world that have a single digit Erdos Bacon Sabbath number. It's people like Brian May and Stephen Hawking and people like that. And my total number, if you watch the video, I go through it, but mine is 13.
That's really good, though. That's shocking.
Which is the same as Adam Savage from Mythbusters. And unfortunately, Natalie Portman's is 11.
Well, I mean, what are you gonna do?
It's so my Sabbath number is 3 because of a small music track my dad made me shout into a microphone for when I was 6. And he's part of the local rock scene, and he's played with people who have played with Black Sabbath, so that's why my Sabbath number is 3. I spent 3.5 years on a PhD publishing papers, and I only have a Nerdosh number of 6. So if anybody's listening and they have a Nerdosh number of 2 or 3, and they would like to credit me as a co-author, I'll help towards your research. Then yeah, please reach out. I want to see if I can get a single digit EBS.
I wonder if there's anything like that in computer science. I kind of doubt it.
Well, I mean, computer science research papers, going through into computer science research versus math that's quite close.
Yeah,
it's a bit different for me because it's a bit chemistry. My route was very convoluted. I'd much rather have it simplified. So
it's messed up. All right, what else?
I mean, it was a fun video. And now, if you search for that term on YouTube, I think there's actually only 2 or 3 videos that mention it, and mine should be number 1 now.
Oh yeah, Tech Potato. You got your URL. You've had your URL for a while, but 10,000 subs. There's a link to it in the description. Should click that and sub and all that. That's really good. There's some stuff happening.
It's there's about 18 things I want to do on video, but I need to have time to do it.
Yeah, time is the enemy. There's never enough time.
In like Amazon Prime Day, I did the I got some stuff. I got some of those high-end Western Digital USB hard drives. So I kind of want to do how to shuck a USB hard drive video. I've bought one of these arms so I can just. I mean, I know you've got the camera up there pointing down.
Oh yeah. I didn't frame it real good, so it's like, hello, how's it going? Yeah, I can't switch to that one. It doesn't have its power brick is over in the other one, so.
Though you are talking to somebody who kind of lives off of Logitech stuff. I mean, it's Razer bestowed upon me a package this week, so now I'm actually using one of the the Razer Kio and the Razer Siren, and they so far seem to be working. I think it's more my internet connection is working worse than the hardware.
The whole video conferencing thing has completely transformed everything because there's also those really inexpensive HDMI frame grabbers that'll do 1080p 30 no problem. They're like $5 or $10, and so there's a whole cottage industry of people that are taking really good sensors from older digital cameras and just stripping away, like they were never actually used in a digital camera, but they take the sensor, package it up really cheaply with just HDMI out, and then you can combine that with a frame grabber, and you end up with a really good, like a shockingly good webcam, because Logitech and those other companies are like, we'll just use the tiny micro CMOS sensor. And it's like, come on, guys, come on.
Yeah. The problem with those is you gotta watch out if I mean, okay, it's okay for video conferencing, but if you want to do any sort of content generation,
Yeah,
you know, it's video JPEG, was it MJPEG output or something?
yeah, some
Which
of them,
can,
yeah,
yeah, which are
which looks
artifacts.
a little crunchy. It's fixed bit rate, so like if you know,
Yeah,
have a lot going on, then it's all of a sudden it's not great.
I mean, I've started watching more of our good friend Epos Fox on all this stuff, and it's crazy how far the rabbit hole goes on something that you haven't necessarily been connected, an industry you haven't been connected to in a while.
Yeah, yeah.
So
Yeah. Some of the chat wonders, you know, what does this mean for the data center? I am beyond excited for a 32 core Threadripper based on Zen 3, because I don't know what I'm going to do with that much compute horsepower. Like I've got a 3970X for like my main work machine, and it pretty well keeps up with everything that I ask of it. And I don't know what I'm going to do with more horsepower. I mean, I'm sure I'll find something. Don't worry. But good lord, it's kind of bananas.
it's I mean, AMD said what 19% IPC for Zen 3.
Yeah.
In the Anantech review, we actually got like 18.81, so 19%, which is like the third time in a row AMD has been exactly correct to the number in our testing, which is testament to AMD's legal team, I guess, for allowing to publish that number. But it's accurate, and when it comes down to looking at next gen epics, Milans, you got to wonder, well, are they gonna keep the same power envelope and go for the higher frequency with the extra efficiency, or will they keep the same frequency but use a lot less power? I mean,
the market
sell
probably
a market,
demands both, so we'll probably see
yeah,
both SKUs.
and then increase in load store resources, that's going to play a huge role. Increased FMAs means that these epics are going to be used a lot more for machine learning and more for compute tasks. Because I mean, what the big thing about Naples was storage.
Yeah.
Because of all the PCIe 4. Rome, we moved more into sort of HPC type stuff with was it the ITRS Hawk supercomputer, leveraging 2.35 gigahertz, 64 core Romes. As we move into Milan, we're just going to get, because compute is the only thing that changes, right?
Yeah.
We're just going to have more compute focused implementations. The question comes back to is AMD's TSMC allocation, how many chips are they making, how good are the bins. One of my arguments in the Ryzen 5000 review is, why haven't they done a 5 gigahertz version of Ryzen 5000? So, well, if your chip is that good, maybe they prefer to sell it in an EPIC. If the chiplet is that good, they'll much use it in an EPIC,
Yeah.
And sell that chip for a few $1,000s than give it to somebody in hand for a few hundred.
Yeah, we don't know if 5 gigahertz implies that that die has less or more leakage or whatever the magic variant is. Because 5 gigahertz could also imply that it's super power efficient, which would be great for having rock solid stability at a lesser clock speed. But yeah, for those epic applications, it could be perfect.
So with the Ryzen 5000 series, for anybody who hasn't seen the reviews, the 5950X with its 4.9 gigahertz turbo can actually go above 5 gigahertz in precision boost. Not precision boost overdrive, just standard precision boost, which is what they used to call extreme frequency range. If you actually look at the registers on the silicon and in the Agizas, that chip actually has a maximum frequency entry of 5025. So it does. So AMD on the box says 4.9, on the CPU says 5025.
Yeah.
And in the OS we're detecting 5050.
Yeah.
Now you could argue, well, why didn't AMD go and promote, hey, we've got another 5 gigahertz CPU, it's our second ever, because they did do one in 2013, if you remember, on Bulldozer. But no, we've got it on 7 nanometer, and it's incredibly power efficient. reason I think they didn't do that is because if they had done that, then that would be the only conversation that we're having today.
Yeah.
Everybody would have pointed to the performance of Zen 3 as, look, 5 gigahertz. They wouldn't now, as what we're doing, turning around saying there's actually all these core improvements, and we're actually seeing improvements to memory, and there's a lot of all different things in play. That's a much better discussion for AMD to have with regards its technical prowess and for its investors, rather than simply saying 5 gigahertz.
It's funny on the 5900X. It's the DMI decode value on it is 4950. So
Yeah.
and you can go in PBO and you can give it the last 50 megahertz and it will do it. But the actual real world gains from that is kind of dubious and maybe even moves backward a little bit because they've really shockingly closely bend these CPUs. It's sort of insane. And the 3900X or the 5900X, the other thing with it is with the 3900X 3000 series Ryzen, there was one really, really well bend chiplet, and then the other one struggled to do like 4.4. And I got my hands on a total of like 10 or 12 of those. And it was pretty consistent except for like right at the very end of the production run, or right at the very beginning of 2020. And then I could sort of start to see 4.4, 4.5, 4.6 on the second chiplet. Just I'm curious. I gotta poke at it. And the chiplet situation on the 5900X seems way different because it's maybe slightly worse, but it's not dramatically worse because the all core, the out of the box all core boosting behavior, depending on what you're doing, and especially in like some all core workloads in Linux, but that are not really super heavy on computation on the CPU. It'll just stay at like 4.6 or 4.7 gigahertz because I gather that the CPU would leave performance on the table if it ramped down because it needs time to ramp back up, but it's not really doing stuff for the full time. So 4.6 gigahertz all core boost is not super unheard of, at least in Linux. And the boosts were really high on both chiplets. I mean, I was like seeing like 4.8, but 4.950 in Linux I could see on 2 cores, and that's pretty insane.
The issue with the dual chiplets on Ryzen 5000 I found was that, I mean, naturally you get some variation between the chiplets due to binning and everything. When I was loading up the cores on the chiplets, when I do my core loading test, I load one chiplet first on all 8 or all 6 cores, and then the other. And I was noticing that the power draw reported for the second chiplet in both of my chips cases, the power loading per core was lower. So if I change over to here, if people can see this, let's go to the 5900X. Is that visible?
Yeah.
Yeah. So I mean, if we look at 6 cores loaded, we're seeing about anywhere from 14.2 to 15 watts per core when we load it. Then when we load up the seventh core, so we go onto the second chiplet, we're only running at 13 watts. And you can see 2 very distinct patterns of 6 here, where the second chiplet per core is running 1 watt lower. And it's not loading here because it looks like an Antec still isn't working. But we saw the same thing with the 5950X, which either means that the first chiplet in use all the time is kind of more leaky, just because it's consuming more power, or this means AMD has the power to use different voltages on the chiplets as well. So we might be seeing some of that as well, some of that profile. Unreadable and blurry. Okay, sorry. It's on an Antec page 6.
Yeah, just go to the Antec website because it's there. I guess we're streaming at 1080p, so it's not great. Like through Discord and through everything else, it's like, oh, too many layers of compression. But it's there. You can check it out.
Yeah.
Yeah, that's a good point. I'm surprised that it's within a watt or two, but yeah, that makes sense because power budget is a thing on the 3000 series CPUs. Your boost clocks were affected whether or not you were using PCI Express 4. I think they fixed that in later Agiza, but it almost seemed like the first Agiza for the 3000 series chips didn't take the power budget of the I/O die into account because the I/O die is going to use a lot more power running PCI Express 4 NVMe and PCI Express 4 GPU. So it's like, wait, what happened to my boosts? It's like, there's a fixed power budget here, fella. Now it doesn't seem like it matters.
It's I asked Mark Papermaster, AMD's chief technology officer, about the I/O die, because the I/O die idle uses about 10 to 15 watts, and when you're dealing with like a 65-watt chip, you're essentially using what 15 to 20% of your power budget just on the I/O die, and you'd want arguably to use that more for the chiplets so you can run at a higher frequency. And because the I/O die hasn't changed from Ryzen 3000 to Ryzen 5000, that sort of power stays the same. And he turned around and said, yeah, wait until next generation, maybe. Stuff might happen. So it's the beauty of the chiplet design has meant that AMD can chop and change, and as long as they adhere to the standards every time that they've set themselves with packaging and power distribution, then yeah, I mean, this is essentially a PC on a smaller scale.
We got another question. Hirako, I think. I've been struggling with this question. Does the larger cache of the 2 compute die design found in Ryzen 9 have any tangible benefit over the R7, R5? So for me, because I'm a crazy person, it absolutely does, but it depends on how you load the chiplets. So having a background task that has nothing to do with my foreground task that's living on, the second chiplet while I'm working in the foreground on the first chiplet, that is a glorious computational experience. It is a sight to behold. It is amazing. The system is fast and responsive no matter what I'm doing. It's like the old days when I had a 2-socket system where I had 2 physical CPUs in the computer. It's like, this is amazing and glorious. Normal people, no, it's fine.
Also, from a single thread perspective, no, there is no difference.
Yes.
Because each core can only access the L3 cache on its own die directly. So if you do a cache latency profile, as soon as you get to 32 megs, it goes straight up because you're going out to DRAM. When that's on both the single chiplet and the dual chiplet. Just because the other chiplet has 32 megs doesn't mean you can use it in the same way.
You get a tiny little benefit because I think it can fetch, because it could before. Like if you needed something in some other, it could. It's still faster than main memory, but mostly no. It only matters for like heavy multitasking.
I think we recorded 80 nanoseconds chiplet to chiplet, whereas if you go out into main memory, you're talking 150 or what have you. So there is benefits there, and if you're running virtual machines, you can limit a virtual machine to a chiplet.
Yeah, and that works well. That works shockingly well. AMD has also, at the risk of creating leaks or whatever, they really published a lot of changes to the Linux kernel ahead of the 5000 release. That's where I got a lot of good leads and good information about what was going on, like changes under the hood. And it's really good to see AMD treat Linux like a first-class citizen and have really smart people working on the Linux kernel changes, because you still need to take into account some things with the multi-chiplet design, but games like Far Cry 5 where they just refused for whatever reason to make any kind of changes or optimizations to deal with the whole multiple CCX per CCD compute chiplet thing. Most of those idiosyncrasies in performance from those types of applications are completely gone, and everything else that even remotely a little bit takes into account the architecture of Zen, the performance is through the roof. Like PlayerUnknown's Battlegrounds, where it really is 35 to 45% in our testing in terms of single thread performance improvement.
I think when we move on to the epics, one of the big customers here is going to be the hyperscalers, because they will want the more performance. The question always comes about is, well, if you're a customer at one of these hyperscalers and you want a Rome or you want a future Milan, do I want an instance size that's larger than a chiplet? I mean, you remember Intel's infamous presentation where they spoke about glue, and what one of the arguments there was, if you go beyond a CCX with your VM, you're going to get degraded performance. Yeah. Now with the 8-core CCX, obviously that makes it a lot nicer this time around. So any hyperscaler that's offering Milan instances is going to say, well, you will want an 8 core as your base because that's where your best performance is. AMD, when designing these chiplets and how many cores they put in a CCX, that is one of the considerations they use, because hyperscalers means billions of dollars.
Yeah.
So if you have the right instance size for their customer base, or even for their own internal deployments, right? It's nobody has any real insight into what these hyperscalers are using internally, aside from the people that actually sell them the hardware for them to use internally. So next time when Zen 4 comes around, are we going to move to more cores in a chiplet? Are we going to move to 16 core chiplets but using 2 8 core CCXs? Or
it's
it's
it's a bright future.
And hey, maybe are they going to move to 5 nanometer? Are they going to improve on the density? Are they going to put cache in the IO die? Is it
Probably.
so,
I bet we see a launch where they're mixing lithographies. Like at the low end, they could just use something inexpensive, maybe the 7 nanometer, the existing 7 nanometer process, and then at the really high end, maybe they could move some of it to 5 nanometers, because honestly, Epic Rome solves a lot of those kind of problems already. And except for like power and density and performance and stuff like that, it's a really good mid-range server. Even in the context of like an available Milan with 19% IPC, it's like you still are doing pretty good in terms of like server capacity and workload and IO capacity and stuff like that. So, they could just sell a tweaked version of that process and then something really high end with 5 nanometers for Milan plus plus or whatever, and that would be fine. People would still buy that a lot.
If they can do a package design that could either take 7 nanometer or 5 nanometer chiplets, and they can mix and match based on SKU.
Yeah, that would be something.
That would be a really nice goal. Okay, so question for you, Mr. Epic Man. It's like Superman, Epic Man. Current Rome 64 core Epic 7742 SEP is 6950 US, correct?
Roughly.
Milan 64 core high end Epic 10K.
999. 999.99.
As long as I get to place the decimal point in that price, I'm with you.
Yeah, I think I would be surprised if it's not 10K. If it's less than 10K, then AMD's just being super aggressive for adoption. But there were so many Xeons that entered the secondary market last quarter and the quarter before that, like thousands and thousands. But there wasn't any motherboards or chassis or anything that showed up. So I think a lot of the hyperscalers, most of them, I think, got a deal with Intel where they moved from their 12 and 18 core SKUs up to 28 cores on the existing 3647 sockets.
Mm.
And so they just, because it's an already qualified platform, blah blah blah, and so it was, moving from that 18 core power optimized to 14 nanometer plus 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 with better power characteristics. Like you can get 28 cores in the power envelope of what you got, the Skylake X launch 18 core CPUs for or whatever. I think that definitely happened. But with Milan, you move into even more new hardware features that it goes beyond just performance. Connectivity and latency and memory bandwidth and a few other things. And so I think the upgrade for Milan is going to be a lot more compelling than Rome. So I think that if whatever Milan is, they've got a plan in place for like whatever's beyond Milan for those data center customers to be able to do that same kind of an upgrade if they want. That might be okay. But it's pretty unusual that hyperscalers or anybody would fool with swapping the CPUs, because it's kind of labor intensive, and like they must have gotten a really good deal on those CPUs.
Intel has that financial advantage slide that people like to throw around.
Yeah,
it's MDF, medium density fiber board. No, marketing discretionary funds. Right, it's you buy a bunch of our CPUs and we'll help you promote your next product with Intel logos and stuff.
Caveman Jim's in the chat. We got to be on our best behavior.
you know, I've got to hand it to him. He's been knocking it out of the park with roping people into RISC-V coverage.
Yeah. It's because RISC-V is exciting. I mean, it's an exciting time. RISC-V's in everything. You don't even know it.
He's messaged me a few times, and we've said, let's do some RISC-V content at some point. And I have to find the time, and I just have to find the angle. Right? It's whenever these you can always talk about these sort of things holistically, but what's my angle going to be?
This is my. Oh wait, actually, I have a thing for that. 1 second.
Please tell me you're not going to get a wafer.
This is my my ITX system waiting for the RISC-V ITX motherboard, Caveman Jim. It's all ready to go. It's right here. It's gonna be amazing. It's a small form factor ITX. It's ready to go. Just let me know.
When a project gets you excited enough that you've pre-purchased all the hardware needed.
I'm just saying. Just saying. I know they're only for developers. It's cool. I can write a kernel module for you if you need proof. It's fine. Just let me know.
What Wendell isn't telling you is that he's designing a chassis which also embeds one of his KVMs. So if you want to buy a RISC-V plus KVM combined unit, then he'll sell you one.
I have toyed with the idea of, like, you do actually need a micro in a KVM at this point because you need to juggle the encryption, and in an ideal world the computer doesn't know that you've unplugged the monitor, but like that's this rabbit hole of insanity. Like if you go that route and you build a micro to manage the connections and the encryption keys and all of the other stuff, it is completely insane. Because then you're like, okay, I've done it, and then G-Sync comes along and it's like, oh no, I have to be able to talk to the FPGA too and have all this extended data in the. Yeah, it's gonna take something with some horsepower.
As long as you don't have to give stuff DMA access and go down that security hole.
Yeah. It's you can't, like, if I did that also, it can't be certified for use in secure environments either. The current KVM is actually usable in a secure environment because each host is isolated from every other host. But technically, that's not the case. You could use the DDC channel to communicate between hosts if you compromise the micro in the KVM. So that's a whole other dimension of crazy.
The thing with the KVM is what I need is I want the KVM when I'm not needing the display output of that machine is to keep telling the machine that display is still connected.
Oh, hang on.
Now he's gone to get a wafer.
I'm back. What you need is the handy level 1 text DisplayPort EDID HDCP feeder. So this box, let me switch angles so you can see. So this, we have DisplayPort out, or no wait, DisplayPort in on this side, DisplayPort out, and HDMI out on that side. This will clone your DisplayPort signals pass through, but it'll clone it to HDMI. This thing will find the modes that are compatible between your HDMI display and your DisplayPort display and send that signal to your computer. But when you press and hold the button, this will memorize the EDID of the display that you got plugged in, and then when you unplug the monitor, this keeps reporting to the computer that you have a monitor plugged in because this is your monitor technically.
Ah. That sounds good.
It's only DisplayPort 1.2, however. So 4K 60, will 4K 60 fit in your use case? I'm working on the 1.4 version, but it's not going to be ready until at least summer 2021.
It's because my testing is automated, and the issue I have is when I test games, obviously I want to keep telling the GPU that there's a display connected, even if I want to look at a different display. Because if you move to a different display and then the computer doesn't think that a GPU is connected, it starts changing all your resolution settings. It still runs the benchmark, but it gives you not the value you want.
Yes. I will mail you one to try if you want. store.level1text.com. But I will mail you one to try, and I think it will probably solve your problem and work pretty well. You just have to hold the button for 4 seconds to have it enter learn mode, and then because otherwise, when you unplug the monitor, it's like, hey, the monitor's unplugged because it's trying to be helpful. But those are also this is also really useful. So like if you wanted to do the Digital Foundry, the way that they do the external capture, if you wanted to do a game where you add like an FCAT overlay and then you capture it with like an Atomos HDMI capture, this will convert DisplayPort to HDMI so you can use it for HDMI capture, you know, lossless or ProRes or whatever you need.
It's our guy Brett is using an open source tool, and he gets the equivalent of the Digital Foundry output now. I think he's using a Blackmagic capture card. All I know is that 10 seconds of video was 4 gigabytes.
Yeah, it's not. It's not a lot of fun.
RAW. Yeah.
But
yeah, no. The issue is when I have 4 machines running games simultaneously, I only want 1 monitor, right? I don't want 4, because that just consumes power.
Yeah.
Which so for your machine, for your little box, I would need 4 of those.
Yep. And they run off USB though, so they come with a USB cable. You just plug it into a USB port, and then you're good to go.
Okay. Have to save my pennies. Have to make my channel. Might have to make my channel more successful.
I might know a guy that has some coupons, so we can figure that out. It's not a problem.
I mean, it's I currently have 1, 2, 3, 4, 5 4K monitors in my 130 square foot office. plus the 2 1080p's I actually use for working.
I quit using 1080p for work a long time ago.
The thing is, these were $100 for an IPS 1080p 24-inch panel. It's what I'm thinking of moving to, is the portable displays you can now get on Amazon for $100, $200. You can get like 3200 by 1800 displays for about $200 now on that, using IPS panels, but they fit into those tablet holders on tripods and arms.
Yeah.
So if I get 4 of those, I get the equivalent of a 27-inch monitor, but it's 6400 by 3600 display.
This little tiny display is 2048 by 1536, and it's 9 inches in diagonal. So, and it's DisplayPort. It's embedded DisplayPort. So
yeah, just run 4 of those off of tablet holders, and
yeah, pretty much.
And then if they're on arms, you can just move them away when you need to do a piece to camera.
It's on an arm.
Yeah.
It's an old lamp, so that's fun.
It's on an arm, but it's running RISC-V.
Yeah, that would be fun. It's the little controller for the monitor to turn the backlight on and off is an Atmel, which would probably be like as soon as there's a RISC-V like Atmel where it's got a little bit of programmable flash and an EEPROM and some other stuff, that'll be nice.
Speaking of displays, how much do you like 16 by 10 displays?
A lot.
Do you know of any laptops with 16 by 10 displays, modern ones?
No. The closest thing is like the Surface Book, but it's a 3x2.
Razer just announced one.
Ooh, that's nice.
So imagine a Razer Blade Stealth 13 in silver, right? Put a Tiger Lake inside, the top 1185 G7, 2 Thunderbolt 4 ports, both do power, Type A port, per key backlighting, 13.4-inch display at 3840 by 2400.
I would like that. That's a thing that exists. 4K
16 by 10 13-inch display.
I want it. I don't care.
Okay, so this is fully integrated graphics, no discrete graphics. Comes with 16 gig LPDDR4X, 512 gig SSD. How much would you pay for that?
Probably around 2,800, 3,200, something like that.
3,200.
If it well, oh, it doesn't have a discrete GPU though, does it?
And
Hmm.
it's a 13-inch ultra portable. It's trying to be. It's Intel Evo.
I don't know. I probably would pay more. Probably I would pay a lot for that because the last laptop I got that was kind of high spec like that was like $3,000. But
Yeah, well, this is coming to the market for
that seems.
2 grand.
I mean, but there's no discrete GPU though,
Yes.
so that seems like I don't know. Is Intel Xe graphics that good?
Well, I mean, it depends what you want to use it for. I mean, you already got a high. You've already got it. It is a 4K 16:10 display, so you could argue, well, that's going to drain the battery. But it is Intel Evo certified, so it has that sort of sub 1 watt display stuff.
Hmm.
So the battery life is going to be. It's designed to be a professional or a prosumer type device on the road device.
I think the
So working on an airplane, I think that'd be amazing.
is it laptop only or is it a convertible? Like, can you flip the screen all the way back?
I believe it's laptop only
Hmm. I got
because it's a
the
stealth.
last laptop I got like that had a discrete GPU and the display could flip all the way around backwards and I was fairly happy with it.
Is
Um,
that a Yoga
mm,
or a
Probably like
HP
18
Spectre?
months. Yeah, I mean it's been a while. The laptop I got before that was the Dell XPS 15, but it was the convertible one, and that was the one with the 4-core Kaby Lake and Vega. And I was
Yeah.
really happy with that, except for the battery life. The battery life on that was terrible, but otherwise it was built like a brick, and it was wildly expensive, but it was very fast for at the time.
I mean, wasn't that meant? Wasn't the CPU in it 45 watts and then the GPU a bit more?
Yeah, yeah.
Yeah, it's. I don't know. It's well, this new device is a Razer Book 13. It's called a Razer Book, designed by gamers for professionals.
But there's no GPU. Oh, it's got Thunderbolt, I guess.
Yeah, and that's kind of the Razer use case, right? So
Leviathan Prim says that I feel unprepared to get the knowledge that I'm about to receive. I don't. We're basically just goofing off here. Like
yeah,
it's honestly probably a little. We probably said we probably need to go. So it's fine. It's fine. We're gonna wrap it up. All right. Anybody have any last questions before we go? Yeah, Ryzen 5000. It's a blowout. It's gonna be real interesting to see how Intel responds. Micro Center had 9900K for $300, which seems like a really good deal.
and if you're pondering whether you should plump for it, because $300 for a 6 core is still quite a lot, I say wait until January, February, when the 400 series motherboards get the BIOSes to come out and stocks come out into the market, and we're seeing some sort of balancing with the 3000 series pricing. You might see something more interesting there, or perhaps AMD might announce something at CES for the rest of the year, which might take your
Yeah.
fancy.
Yeah, it is true that on the AM4 socket, you've got a lot more flexibility. Maybe you could build your entire system and get a potato class AM4 CPU for like $5. I mean, I've heard they're in like Cracker Jack boxes now. You get like the old 1600 for like $8 or whatever. Not really.
It's
I'm joking.
I thought that was all about the Pentiums. Where'd you get your CPU and a box of Cracker Jacks?
What kind of chip you got in there? A Dorito?
Yeah, with 100 gigabytes of RAM. Oh,
Yeah,
yeah.
yeah.
Oh, what's special about that? I've got that in a stick.
128 gigs of RAM. Oh yeah, I've got. I don't know if it's on Patreon or not yet, but I do have a video about 128 gig kits with this for 432 gig sticks of memory. It's basically okay. I got 3600 working, but it matters a lot what motherboards you use.
It's I've just asked Micron to send me some of those 32 gig sticks, but 3200 JDEC. So no, nothing special. Just so when we go into regression testing, because we're kind of at the end of the whole DDR4 lifetime, right?
Yeah,
We're not going to get anything faster than 3200 on the official spec side. So thinking if I get in some 32 gig dual rank sticks, and then that can be my testing until the day I die on DDR4.
yeah. That's smart. That's a good move. Of course, it'll probably be because it's JDAC. It'll probably be cast latency like 22. But
I'm fine with that.
No. Yeah, it's probably fine. All right. Any
It's
other
all
last
good.
questions?
I think chat's about 30 seconds behind. If anybody has heard fireworks going off, it's because it's fireworks night in the UK, and I can hear them, and they're really loud.
Also, as
What?
evidenced by my amazing review intro. Remember the 5th of November, the Zen 3 benchmarks, uh, or the Zen 3 launch and benchmark plots.
It's. I started watching that, and after 15 seconds, I was like, yeah, okay, get on with it. And after 30 seconds, I was like, how long is he gonna go? And then after 45 seconds, it's like, okay, this was really planned. And after a minute, it's how many more words are there in the English language? Dude,
No, a rocket. It's
crazy.
wrecked. That's probably my favorite part. Yeah, I did go a little long in retrospect. I probably should have shortened it a bit. Oh well.
It. Well, to be honest, I think you could cut out the video and just post it as a clip.
Listen, it's quarantine. I haven't had a lot of human contact. A little bit of cabin fever. A little bit, it's just one of those things. I was inspired to do it. Did you ever watch Close Encounters and the dude's making the thing out of mashed potatoes? It was kind of like that.
It's don't say lockdown. UK went back into lockdown today for a month.
Oh,
Yeah.
Good luck. Good
Did
luck in
Wendell ever get
December. I don't know.
Did Wendell ever get a Power 9 Blackbird board?
No. Gosh, I really want to do that. No, I never did. I mean, just the history of it. Really exciting.
How do you feel about DDR5 not being able to go below CAS 22? That doesn't matter
Yeah.
because your frequency is so much higher. If you go to a Nantec and search for, I won't say DDR5 because, yeah, if you search for DDR5 on a Nantec, I did a really nice write-up about all the JDEC DDR5 specs and what the latency actually means in terms of nanoseconds. And I went through all the way from DDR5 4800 or whatever the lowest one is, all the way down to DDR5 8400, which is where the spec kind of ends. So
the latency has basically plateaued, right? The latency, like the actual real measured latency, is basically unchanged from like fast DDR3 until now. So the number doesn't really matter that much.
And my article on Nantec, starts at SDR and then goes through DDR1, DDR2, all the way through to all the DDR5 specs, and you can see there that it's leveling out. So, I mean, don't get me wrong. Consumer memory obviously will go beyond because what we should be on CAS latency 22 at 3200, but we're actually dealing with CAS latency 14 kits now.
Yeah.
So,
what do you think of the AMD Xilinx deal? What do you expect out of it? What do you think? We talked a little bit about that earlier. We both sort of hope that AMD will leave them alone for a bit and then cherry pick stuff.
Did you do a dedicated video on that, or did you cover it in the news?
Yeah, we mentioned it in the news, and that was pretty much it.
I've got a video on AMD's financials, their disclosure. So their financial call was 60 minutes. My video was 90.
There's so many implications. Yeah, I follow that. I saw part of that. That was really good. You should check that out.
It's if you go to, I think, 1 hour, the 1 hour 17 mark is when I kind of go off the written stuff and into my own thoughts. I cover a lot of what I think AMD Xilinx and what AMD has to do, and as Wendell said, leave them alone, stage one. And what does AMD get out of it, and why even would AMD do it? Because I don't want anybody else to have access to Xilinx.
Yeah. Well, now it's kind of funny. You mentioned also too the whole Xilinx AMD NVIDIA love triangle too, right?
Oh, yeah, because some of NVIDIA Mellanox's products use Xilinx FPGAs. So when I think that was a tweet, and I tweeted that, and then it came to pass that they use a lot fewer Xilinx FPGAs than they used to in the past. So it's not so much of an issue that I perhaps shit posted it to be about. Basically,
it's a love triangle. No, it's fine. It turns out more than It's just that the Altera Intel acquisition caught a lot of people with their pants down, and then all of a sudden it was like, oh, who else makes FPGAs?
Lattice, NXP.
So
Who else uses FPGAs in high performance mode?
yeah,
Yeah.
so fun stuff. All right, I think that's about it for the stream. Thanks everybody. Let's do this again.
Yeah. Level 1 text, tech potato.
It's in
Twitter.
the description. Click the stuff. Subscribe. Recently released Ryzen with restrictions, with benchmark results rescinded, or results restrictions rescinded.
Wendell's got a review. Go watch.
Okay, one last question. How's the FX Pro 1 doing? It's fine, but the keyboard is not super comfortable, but it's effective. It's functional. All right, we go.
XDA developers did their own version. I want that.
Oh yeah, me too. That would be good.